Hi everyone. For our first day of enrichment, I am going to take you through an experiment that you could do at home this summer. So if you have little siblings who are driving you nuts, or you have some friends you want to impress, you could do this demonstration for them and you could explain to them how it all works because you're so smart and you're a biology student. So admittedly, I'm going to be posting this for both AP and honors biology. The AP students, you should definitely know how this all works. The honors students, this is a good introduction to AP Bio if you're signed up for that next year. We're going to be dealing with water for this experiment and the properties of water and how they work. So if you wanted to do this experiment at home, you need a couple materials, and you probably have them all in your kitchen. You need 5 cups, any kind of cup. You need paper towels, food coloring, and water. So I'm going to show you how to set this experiment up. I'm not super tech savvy, so I'm going to just be screencasting myself here on the camera. So 5 cups, 2 of them no water. Bring this down a little bit. 2 of them no water, 3 of them with water. And you place them every other cup. So the 2 that do not have water are here in the middle, and then the 3 that have water, 2 on the ends, 1 in the middle. Okay? So then I take my food coloring. You can pick any 3 colors that you want. If you don't have 3 colors, you could do like a gradient where you put a lot of, one color into 1 cup, a little less, even less, to give you different shades of the colors. The colors aren't super important, but I'm choosing 3. So I'm going to drop it in, my red. As far as the water goes, you want the water level up. The higher on the cup, the faster this will work. So if you have really little siblings that don't have a high attention span and you want to impress them quicker, I recommend filling the water up very high to the top and making sure that you use hotter water. You know from your chemistry, right? The higher the temperature, the faster the molecules move. Just a tip. All right, so we're gonna get this going here. All right. Make sure you use a different stirring utensil each time so that you don't mix up your colors. All right, so once you have that set up, remember these still have no water in them, you're gonna take some strips of paper towel. So I cut them, they're really thin. You don't need a lot. In fact, the less the better. Less is more in this case. So I'm gonna take my paper towel piece and kind of fold it in half. And I'm gonna start on one end, dip it into the first cup, and then place it into the next cup in the line. Gonna do the same thing with the next one. All right. And then the next one here. Admittedly, I'm missing a paper towel. Hold, please. That was embarrassing, sorry. All right, so take my last piece of paper towel, stick it in here, and now I'm all set up to go. Now, you can already start to see what is happening here, hence why they call it the walking water experiment. What I'd like you to do is take a minute and think about what you think will happen to these 2 cups here in the middle. What are your predictions? Why do you think that would happen? Do you think that they will gain any water? Do you think they'll stay empty? What about the color of the water? Will it change? Will it be the same as these colors? What are your predictions? Go ahead and make them now. I'm going to pause the video and give this some time to work. And through the magic of technology, we'll come back once something has happened. All right, welcome back. Due to the magic of pause, You can see here in our cups that we have, actually you can't see because this thing's on the screen, sorry. You can see here that we have some changes that have occurred. Looking at our paper towels first, now they are a bit more saturated and almost totally matching the color of the cup from which they're coming from, right? And then some other observations. This is not a reflection or a glare, but there is some water in the bottom of this cup. It is red in color. I don't see anything happening in this cup quite yet, but you can imagine that if I were to leave this much longer, what would probably continue to happen, right? Or what would happen? You would make some predictions or apply your predictions and what you thought was going to happen. It's been about 20 minutes since I paused, so if you wanted to leave this much longer, you absolutely could. I'm going to show you a picture of what this would look like at the end, so that you get an idea. If you're trying to show this to like little siblings or something like that, you got about a 20-minute window of time before something starts to actually happen that you could show them. So my AP biology students, you're probably thinking about this already and how this can occur, thinking about some of those properties of water. So let's talk about water. So you guys all know from chemistry, even if you're in honors biology, right, that your water molecule has one oxygen atom and two hydrogen atoms. The hydrogen atoms are positively charged, and the oxygen atom has a lot of electrons around it, so it's electronegative or it has a negative charge. The bond that forms between water molecules is called a hydrogen bond. This bond forms between the negatively charged oxygen and the positively charged hydrogen of another molecule. So water molecules are able to form lots of hydrogen bonds, which allows for a lot of water's properties. One of the main ones that we see here is when you have many water molecules together, sticking together like this, they call that cohesion. So if you're taking AP Bio in the fall, you'll hear about cohesion. We start the year off talking about the properties of water. If you took AP Bio already, you should know this, right? And my AP Bio students, you're probably thinking about the next property of water here. So we have water sticking to itself inside of our cups and on our paper towels. But what allows the water to stick to the paper towel itself is this property called adhesion. So adhesion is when water sticks to something else, another surface. It's why water is able to bead up like this. If you've ever done the dropping water on a penny, I guess it's kind of like I wouldn't call it a lab. We do it in AP Bio, but just like an activity, right? See how many drops you can get. It's why water beads up on the hood of a car, in this leaf. It's because the water molecules are not only sticking to themselves through those hydrogen bonds, but there are also bonds forming between the water molecules and the surface that it's sticking on. So the water is able to bind to itself. It's able to bind to the paper towel, and through this process of essentially moving from the cup up the paper towel and into the next cup, this process is called capillary action. So it's the combination of cohesion and adhesion, water sticking to itself and water sticking to the paper towel, that allows it to move or walk. That's why we call it the walking water experiment. So it starts in the cup it starts in one cup and then is able to use the paper towel as a means of transport or capillary action to get to the next cup and start to fill it. So if you were doing this as an experiment and you wanted to, if you had siblings that were maybe like middle school age and you wanted to work with them to help them come up with ways they could change the variables of this experiment, you could try different things. You could alter the temperature of the water, but of course you know, since you are a chemistry student, that the hotter something is, the faster the molecules move, more kinetic energy. So the hotter the water, the quicker this experiment will happen. You could change the type of paper that you use. Instead of paper towel, you could do maybe toilet paper. I know toilet paper's a little scarce right now. It's coming back on the shelves. You could use tissue paper. You could use a tissue. You could compare different brands to one another, see which one's the fastest. If you really had time and wanted to try different things, brand of paper towel. Others, can you think of other experiments or independent variables or variables that you could change about this experiment? If you think of any good ones, you could post them as a comment on this video that I'll be posting today for Google Classroom. And then if you're thinking about, well, what happened? I'll go back to my camera here so you can see kind of what else is going on. So we have now some blue water dripping into this cup, and you can imagine that the yellow will be doing the same. We still have some red accumulating in this cup, and you imagine the blue will be doing the same. So what do you think will actually happen? At the end of this process or experiment, you should get, now this is, I left this sitting out for an entire day and came back the next day. You have water now filling up the empty cups, and you have, it's kind of hard to see, but this is supposed to be like a greenish color, right? And this is supposed to be like a purple. It came out very, very dark, but this is what it would look like at the end, essentially. You would have water filling the cups and water that is the combination of the two colors, which is why we call it the walking water experiment. So this is the combination of cohesion and adhesion leading to capillary action, which allows the water to essentially walk and move from one cup to the other. So if you thought this was cool, or you want to add any variables that you could think of to change this experiment, feel free to post them. Feel free to use this with your siblings this summer, or if you're trying to impress somebody, you want to show them that you can make water walk, feel free to use this too. And if you have any questions about this, feel free to post that as well. Alrighty, thank you guys. Enjoy the rest of your day.